Okay, we've got a table of data. Okay, we've got to be clear about what's going on. Okay, he's expected to take 1 hour of the for the services, and he's actually subtracting an hour from all of the raw data, okay, and just recording the difference. So this is data about differences, and it's worth just taking a while to think about what a value, say, of 3 would mean. 3 would mean the answer to his time after the 60 minutes, after the 1 hour is taken away, would be 3. So a value of 3 in the difference column will correspond to him having taken actually 1 hour and 3 minutes, 63 minutes to do that service. So we have to understand what the data means, and when we're using differences, and when we have to think about the original time it took. Okay, so on to part A. The first thing we've got to do is to calculate estimates of the mean and standard deviation of these differences. So we don't have to do anything clever here, we're just working with the differences. Now we want a mean and standard deviation from data. So you're going to be using your calculator. You're going to need to be very careful to have it in the right mode. So you've probably been doing some work with correlation and regression previously on this paper. Okay, but the mode we need for just basic statistics from a single variable is not the same mode. So make sure you go into the correct statistics mode in the first place. And then we haven't got the exact values. That's why it uses the word estimates. I don't know whether the times in this interval were -4 or -2 or something in between. Okay, so therefore for each of these intervals I have to use the midpoint. So you can do it on the original table. Okay, the disadvantage of that is that no one can then see your work, so it's worth actually listing the midpoints to get a method mark in your answer. So these are all fairly easy categories to find the midpoint of. So you enter those as your values, the midpoints I should say, as your values on your calculator. You enter the frequencies and your calculator will tell you the mean and standard deviation. Okay, then you have to do, this is a simple scaling here, which is very much common sense. So if we now think about the original service times, remember the differences you've got here are the original times with 60 minutes subtracted. So we've got to work backwards to what the mean and the standard deviation would be for the original times, and bearing in mind how scaling can affect the mean when we add a value to everything, and how that affects the standard deviation, you should be able to adjust or not adjust just your previous answers to the correct ones here. And then, okay, the next thing, it says 98% confidence interval. So confidence intervals are always a set method. So you need 4 things. You need an X bar value, you need a sigma value, you need an N value, and you need a Z value. Okay, now normally X bar, sigma, and N are all things you can find in the question. All right, now we have got an X bar definitely, because we've got a sample mean. We've got an N definitely. Always for sigma, check to see if you're given the actual standard deviation of the time separately from the data. So are we given a standard deviation of his times? And the answer is we're not. That doesn't get given in the question. So therefore we have to rely on the estimate of the standard deviation that we got in the previous part. But if they tell you the actual standard deviation, then your estimate you won't use your estimate because you've got the real one. But we haven't got the real one this time, so we use the estimated one. So then there's a formula for confidence intervals. Look it up. It's X bar plus or minus something times something over something. Okay, put in the correct values here. Oh right, this Z I need to just remember, we need to look at a picture like this for Z. We need to show the 98% on the picture. You need to work out the probability hanging off each end, and that gives you a p-value that you can look up using normal inverse on your calculator, and that can, depending on which value you choose to enter, can give you either the negative or the positive value of Z. When you're summarizing here and using the formula, I suggest you always substitute in a positive value for Z, because that's what the mark scheme is expecting you to do. Okay, so have clear values for these 4 things, put them in, do the calculation once with a minus, once with a plus, and write down your answer. And if you put it in square brackets like that, with the lower value here and the upper value there, you should be fine. And then we've got to give a reason why this confidence interval is approximate rather than exact. Okay, well, it comes from some of the things we've used in this formula. Here and here come from this part here. So what word in part A, okay, is relevant when we talk about the values of x bar and of sigma that we've actually come up with? Are they exact values or are they something else? Now in part C we're dealing with claims. Vernon is claiming two things actually. He's claiming something about actual service times, okay, whether they're more than an hour or whether they're not, and he's also making a claim about the average of the service times, okay. So one of the things, the confidence interval you've got here, okay, is a confidence interval for the population mean. We're 98% confident that the confidence interval will catch the population mean within it. So whether or not your service time of an hour is within the confidence interval is going to help you answer the question about the average boiler service times. So that's one of your two comments you've got to make. But the other one about boiler services more often than not taking more than an hour. For that, you can go back to the original data. This talks about individual services. So remember that this is about differences. So you have to think about which of these differences corresponds to the service lasting more than an hour. And you can do some counting up of frequencies from the table, and you can decide that either the frequencies do or don't support that first claim of Vernon's. So there are two different claims going on. Okay, so we need to give a comment on each of these, and it has to be with justification. Okay, so you can't say, well, we think this claim is justified, we think this claim is probably true, but that one's probably not true, without any reasons. You'll get no marks. You have to give your reasons based on either the confidence interval or the raw data from the table.